Okay. Alright. Okay. Assalamualaikum. Assalamualaikum warahmatullahi wabarakatuh, and very good night to everyone. Alright. So let me share my screen here. Right. So let me share my screen. Okay. So you guys see my screen? Alright. So okay. Wait. Can you guys see now? Alright. Okay. So I just show portion of it lah. I think it's Discord problem. Okay. So alright. So before that, let me introduce my name. My name is Abdul Hadi. So I'm the engineering lead in Runcloud. So basically, I'm handling engineering team in Runcloud. So for today's topic, so basically, I'm going to give some talk about how to be a cloud architect. Right. So actually, I like to have like conversation with you guys. So how many of you guys is actually a developer? I think most of you are developer lah. But how many of you guys is actually web developer? Maybe can put on one of the channel. I'm not sure which channel for this one. General chat. Right. So never mind. So we continue. So basically, this slide, actually I've done this slide before. I think around 2020 or 2021. I'm not sure. In Jom Lunch. So basically, it's the same topic. But this one, I think all of you guys are practically a new talent. So maybe I can just show again lah on this part. Alright. Okay. So disclaimer for this sharing session. Basically, this session is presented by Runcloud engineering team. So basically, all of this content is actually not created by me alone. It's also created by few of our developers. And on what I share here, basically is a startup's point of view. So I think there's the startup point of view. That means that what we see on cloud architect is basically on startup view lah, not on this enterprise level of it or anything. So just a disclaimer lah, right? Okay. So the agenda of this talk is gonna be I will be talking about what is cloud computing, so the category of cloud computing, cloud provider, cloud solution. So then I will talk about what is cloud architect. I'm pretty sure because most of you are developers, so probably you guys already know few of the thing. But this is just a sharing session, so just to recap back about what is cloud architect, and then I will give you some of the cloud architecture. An example, the component of it, and what is the key skill for you guys, a developer wanted to be a cloud architect. And then I will also the journey of Runcloud architecture lah. So basically, when we started, it's not like what we have now. So I will show you guys the journey from Runcloud. So basically, our architecture is improving by time by time. So and then I will show you also you guys on the more cloud solution. Alright. So what is cloud computing? Right? Cloud computing. What is cloud computing? So basically, cloud computing is the computing. That means computer processing infrastructure that is remotely managed outside your premise. So cloud computing basically a server lah. A server which is you connected through remotely outside from your premise. So to understand this concept of cloud computing, I pretty much most of you know about cloud computing because at this time cloud computing is not new. But on my time, I'm not that young, so on my time, it's actually quite new lah, cloud computing. Alright. So before cloud computing, most of the computing power is on premise, or in on premise infrastructure. Okay, so you guys know about computing. So basically, I'm talking here about a server. Alright. So before this, most of the internet connected computing power is yeah, of course, computing for internet we use server, but previously most of the computer are on premise, or most of the server are on premise. That means you install the server on your premise and you link it to the internet. So that's how that's before the cloud computing, right? So then at more time, the how we handle the server is changed. So previously, most of the changes on the server will be done inside the premise, on the premise, right? So for example, back there, if you have some application running, so you need to write your codes, and then go to the, maybe you hosted your server or your web anywhere out there. You need to go there and install on the server manually. So that's how, not primitive, but how old guys do internet stuff. Alright. So but then most of the thing change when company start to have their servers in on premise, but then they wanted to remotely manage it somewhere else. For example, like their servers is maybe on their data center, and then their developer can remotely access their servers without going to the server directly. So that is actually cloud already. But I think that is the common way how people back there doing development. But things keep change when instead of the company itself hosting the server, they're using other people's server. So that's how the cloud computing begin. So actually, there's a lot of advantage on the cloud computing, right? So when we talk about cloud computing as a servers, so if we are using cloud computing, that means we don't actually handle the hardware. So no hardware involved in our development. So basically, for example, if you subscribe to one other person cloud computing, so basically they will the one who handle the hardware and not you. And then because of that, it will be easy maintenance. So you know about servers, right? So sometimes maybe the CPU spike, or maybe the hard disk broken and everything. So it's very hard to maintain the servers. So when it's on premise, when in cloud computing, that means the person that you subscribe to the cloud computing will do it for you. And then since this cloud computing is remotely connected, so collaboration make it easier. So basically, you can access from your office or from your home, and then other person, maybe your colleague, can access it from his home or his office. So something like that. So that's how the cloud computing make it more sense on the internet world. Alright, then of course it's a cost efficient. Reason is, if you buy a server and put it on the data center, everything, so that's probably cost you a lot. But then if you subscribe to a cloud computing, probably it's just back there is expensive lah. But now I think cloud computing is like very cheap and very easy to get. Alright. Okay, so on this discussion, I will talk about two categories for cloud computing. One is a cloud provider or company that provide the cloud solution, and another one is the cloud solution itself. Alright, so the cloud provider, if you can see here, cloud provider is provide the infrastructure such as virtual server and networking to the customer. Alright, so yes, virtual server is the correct word. When I say it's a server, it's not a server, it's a virtual server. Alright, so AWS, Amazon Service, we have AWS, we have Azure, Google Cloud, Alibaba Cloud. So basically, AWS is pretty much the pioneer for this modern cloud provider. So I'm not sure how it started, but I think it started back at 2010. Wow, so long. 10 years ago. So AWS wanted to sell their structure or their infrastructure to other people. So back there, AWS or Amazon, they have their own e-commerce. I think you guys know, right? Amazon core business is e-commerce. So so the boss of AWS, Jeff Bezos, say like, actually our solution can be sold to other people also, and they can use it. They can use our cloud solution pretty much very easy lah. Then then AWS come, this Amazon Web Services come. So the AWS is basically the pioneer on the cloud computing stuff, cloud provider. So basically other big company like Google created Google Cloud, which is almost similar, and then Azure, then Microsoft created Azure, and then after that I think Alibaba create the Alibaba Cloud. So basically pretty much they are the cloud provider. Okay, so then come this new small company, we call it cloud hosting. Alright, so cloud hosting basically they also provide similar solution with the big player like Amazon, AWS, but they give it on much narrower and more targeted solution. Okay, so for example, like I think DigitalOcean also one of the pioneer on this cloud hosting, right? So what DigitalOcean do? They basically not reselling. They're selling their VPS, right? So that's the only thing back there when DigitalOcean started selling VPS, right? So VPS is pretty much more like virtual private server lah. So you get your own server, but it's virtual. So you basically didn't even see that server, right? So then come out along with Upcloud, Linode, and Vultr. They do exactly the same thing as DigitalOcean. Alright. So and this one, because they are selling not selling again selling yeah they're selling a VPS. So actually on the cloud or in the internet area, internet market, somehow few percent also selling a hosting. So selling a hosting is that the one is I can say it's a cloud computing, but that one is different from what we want to show here lah. So basically that is more towards the internet stuff or web stuff, right? So that is but I'm talking here on the cloud provider on the computing level. Alright. Okay, so then come up with this cloud solution. Alright, so when this cloud solution, basically all the tools that we use as a developer to hosted our application, our webs. So and then doing some problem solving and also data manipulating everything on these tools. So for example, like we have Kubernetes. So Kubernetes basically maintain or orchestrating the containers, and then we have Elasticsearch. So Elastic is basically has a lot of tools that they make. They have searching engine. They have dashboard. I think Elasticsearch have a lot of other tools lah. Then come on, MongoDB. MongoDB is no SQL database. I think it's quite common. Usually people use MongoDB for NoSQL. And then NGX. So NGX is a web server to host your web app, your web server. And then we have like Envoy proxy, similar to NGX, but mostly on the container level. You have Redis, Postgres, actually Bitbucket. So actually Bitbucket is for Git hosting, but then also have, I think they have on server level. And actually cloud solution, Runcloud also can be considered as a cloud solution lah. Alright. Okay, so actually there's other all of the solution or software that using cloud is basically a cloud solution, right? So who is this cloud architect? Okay, so the definition of cloud architect is someone who designing cloud environment for development and deployment of a project. Alright. Okay, so basically a cloud architect, I can say a person specifically doing or designing a cloud environment. So because cloud environment can be anything, even to put your, for example, web application inside a server, that also can be considered as a cloud environment, right? So the one who designed to put that thing on the cloud, we call it a cloud architect. Alright. So basically, who actually can use this cloud architect? Who can take this role, right? So nowadays, most of company they're using cloud solution. So and it can be like somehow their deployment or their development stuck somewhere because of this technical debt, and then you can actually have a consultant to help you achieve the best way to solve your deployment issue within the cloud environment. Alright. Then also some, if your company become big or enterprise level, the big client and everything, so basically most of enterprise have a cloud architect. And then even for startup, right? So for startup, I can say probably at the very early age of the startup, the CTO will be the cloud architect lah. And then along the way, probably few of the developers will take up the role and everything. So that's how the cloud architect involved, right? So basically, I will talk a little bit in depth about this cloud architecture. Alright, so I will show you the concept and also the example of this cloud architecture. So basically, how we design the cloud solution. Alright, so basically, if you can see here, this is more on how we handle a web application. Alright, so this is the way that everything is on the cloud solution, or cloud architecture. So basically, on web application level or on the cloud architecture level, there will be a front end and also the back end. So when we call it a front end, in development also we have front end and back end, but this is the term for cloud architecture. So basically, the front end is mostly is the client infrastructure. So what and then it will connected to through the internet. Probably internet, if I go deeper about the internet, it can be like TCP, UDP and everything, but I can tell you it's internet stuff. And then the back end, how actually the cloud architecture working at the back end. Alright, so the example of cloud, so what is the front end for the cloud architecture? Mostly is the user interface, and then user experience. Basically about maybe it can be a web application, mobile app, or even internet of things stuff. So this is the client infrastructure. So this is the front end part, which is mostly the user interface lah. Right? And then for this client infrastructure, basically there's a lot of example that we can show you here. For example, for web framework, basically we can have JavaScript, or not JavaScript, is it JavaScript? Yeah, it's mostly a UI framework lah. We have React, JS, and then Vue. And then, for example, if you have a hybrid application, it can be React Native application. This one is mobile application, React Native, and also Flutter. So, and then for maybe you have a native application, mobile application, and for example, for the web, you can also consider a CDN as a client infrastructure lah. For example, how you handle your asset through the web. So maybe you can use a CDN to distributely amongly between the region, right? Okay. Oh, wait. And then we have the connection between client infrastructure and the front end and also the internet. So basically, the communication between the back end and front end, it can be using REST. So REST, I think pretty much nowadays people using REST. Back there, when I started study computer, somehow they're using SOAP. But that already I think nobody talk about it anymore. But REST API is a standard practice, and also the new era of GraphQL. I think GraphQL pretty much for Facebook, they're using GraphQL for their application. And then also nowadays we have gRPC. So gRPC is Google remote policy, remote, I'm not sure, but it's more like a remote connection through Google, something like that. And then we have WebSocket. So WebSocket is basically also HTTP stuff, but it's more on real time interaction. And also SMPP. Okay, so SMPP is another protocol, also real time, similar to WebSocket. So there's a different way to communicate between the front end and also the back end. Alright, so now we talk about the back end. So basically the back end is where sometimes so most of the front end stuff I can see here, client infrastructure, yes, front end developer focusing on that part. And the back end, so this is where actually the back end developer need to know about so the back end basically all the program that run on the application, basically for data storage and also server. So basically data storage is to store the database, or maybe to store the asset and everything. And then most of the back end nowadays deployment, we have this term continuous integration and continuous deployment, CI/CD, continuous delivery. I'm not sure about the term, but then the tools that currently available for us to do it, we have Circle CI, Drive CI, Jenkins, and also Git deployment lah. But Git deployment, this one is very low one. Alright, okay. So basically in the back end, application most of the time application is used for business logic, how we process the data and everything. So that's for example, like if the user add this form, will we store it, where will we store it, so that's the business logic. And mostly for this application level, most of the time we are using framework like Laravel. So Laravel actually can be done also for client infrastructure, but I'm showing you here is basically Laravel for the back end. Also Django also can be similar, can also be done for client infrastructure, but then Django for the back end. And then Express, so Express is the back end, or Ruby on Rails. So and then the service part. So the service part actually in the cloud architecture, application alone is not enough. For example, like I said, so you have application, store database, store and everything, but actually in the cloud architecture, the way how you do it, you need to have the third party service to handle few of the things. For example, like the service will be the important part for provide utilities to the architecture. For example, like emailing, monitoring, and then for example, if you're using queue in your application, so you need to provide a fast memory. Or for example, if you're using again queue, you need to have a worker, or maybe some service that help your application move faster lah, alright, or move smoothly. Then we have the storage part. So storage I think is quite common. We have database, for example like MySQL, Postgres, NoSQL, and then the file storage S3, Azure storage, and there's a lot lah, like the Wasabi, Backblaze and everything. Alright, so you can see here all of this back end, it should have a management component, which is to handle the function of the architecture. Alright, so basically for this management tools, they're using to monitor the cloud operation, which application is running, which application is not running, which service is running. So basically to help you to monitor all your application on the cloud lah. Right, then it can be automated or manual. Okay, so and also the management part, usually it come with user interface, or for example you do it your architecture yourself, probably you don't have user interface, then you can use command line lah. Alright, and then for the security part, basically on how you secure your architecture, basically you have like how you protect from people to access. Maybe for example you're using Cloudflare to mitigate DDoS, something like that. And also you're using key generation S3 to have your file loaded to your web application and everything. So that's on the part of security. Alright, so basically the component for cloud architecture, you have that I mentioned, the management software, the deployment software, the network, the cloud server, and the cloud storage. So basically these 5 components is the most important part when you designing your cloud architecture. Alright, so we back to the cloud cloud. So how big is actually this cloud, right? So basically when you talk about cloud computing, so it can be, there's so many choices, impact, pricing, compatibility on how you want to design your application. For example, if you are creating some e-commerce, right? Okay, so e-commerce nowadays is quite easy to develop, but to maintain the e-commerce, for example, if your business is small, it's okay, it's no problem. But what happen if so many people order in the same time, and you need to have like very sophisticated solution for your e-commerce, right? So on that part, you actually can choose a well-made solution. For example, you can choose platform as a service. So platform as a service is more example like the hosting that I show you guys up there. So basically, like for example, you put all your cloud solution using DO. Alright, so that's actually can be made like that. So it's a platform as a service. Or you want to have your cloud solution on the software as a service. So software as a service, for example, Runcloud. So Runcloud is also is actually software as a service. So you using our software to actually manage your cloud solution. Alright. Or for example, the thing if become more big, like for example Runcloud itself, Runcloud we cannot put it on platform service anymore. So we need to move towards something bigger, which is infrastructure as a service, or IaaS. So infrastructure is similar to what AWS, Azure, Google Cloud is providing. So that's architecture is actually more complex. Alright. Okay, so what is the common mistake when for this cloud architect? So basically, this I think this one is common lah. You start big for a small project. Alright. For example, I can give you example for about Runcloud. So Runcloud, we start small. So we don't start our technology. For example, we're using Kubernetes. So because we are targeting to become big. No. So as you evolve in a company or in a project, you need to start small at least, but make sure it's ready to grow, something like that. Alright. So and then another common mistake for cloud architect is design infra that developers not ready. Alright. So for example, you have your e-commerce, and then you hired few WordPress developers, right? And they actually basically familiar on updating the component or your development inside a server using SFTP, for example. And then suddenly you move to Kubernetes, which is a totally different thing. And that time maybe developer cannot catch up with the infra, and maybe it's not telling to them lah. So it also gonna give an impact, an issue. For example, like how to maintain after that. Maybe you need to hire another person, for example, right? So that's also quite problematic. Especially nowadays, very hard to get developers. So I think Krenovator is one of a good initiative, a good business to have, because like developers, so they have developer. So and then also picky on choices. Okay, so for example, your CTO, I'm expert on DigitalOcean app platform. Alright. Okay, so I will only use this as my solution. Actually can, no problem. But then, for example, if that solution or that choice cannot grow anymore, or maybe it take more, the cost is too high, right? So basically, also can create an issue lah. So basically, don't picky on your choices. So try to make choices that suit with the current situation, something like that. And of course, another one, do not do enough research. Okay, so for example, you move to Kubernetes, similar to the point number 2, and your developer is not ready. And then actually on the research part, you didn't know that Kubernetes very problematic with firewall, and then so everything then now you have problem with security. So you need to know that, you need to know about all of these things. Alright, okay. So the key skill for cloud architecture, basically this is the standpoint of what we know as a startup, so basically to be a cloud architect, so you need to have very strong technical skill, especially on how the cloud works, and how the basic cloud computing lah. Right, so for example, you know, at least you need to know how to set up a server. At least you need to know how to connect a server. At least so for example, if you learn everything about cloud computing but then never or don't try it at all, so probably it will be a problem with you understand it but your technical skill is lacking, so very hard for you to keep up. Right, so then for of course the background should be know about programming. I think this is not common in IT world. In any IT, even for QA, they should know how to program lah. And then the networking stuff, you know how this networking stuff, for example, how to connect between the servers, so how to secure the connection, HTTPS, SSL, SSH, or how to secure most of the network stuff lah. Alright, and then for the infrastructure, of course you need to know on the infrastructure that you choose. For example, DigitalOcean, you need to know very well about DigitalOcean, and then the tools and the technology that DigitalOcean use. So this is the way or the key skill for cloud architect. Alright, so another part that very important is the communication. So because as a cloud architect, you are not building something from out of nowhere. So basically you need to have discussion among the developers lah. For example, you have for example, I give you before this, you have 2 WordPress developers, right? So what you need to know, what they can cope with. For example, you want to move from standard server or standard hosting, you want to move to Kubernetes. So at least, for example, if they agree, they say they want to learn about this new technology, then it's okay. So that's the communication skill the developer or the cloud architect should have lah. And then do some research within the community. So this one, I think is common skill for developers nowadays. So you join a community, you ask a few things if you don't understand, right? So I think this one is not common lah. And then I think the most important part on the communication skill is asking the right question. So if you have a problem, you should ask the right question, or somehow if you asking or something that you question, your question is not clear enough, and it's gonna be pointless. Alright, okay. And then of course for cloud architect, you should have the leadership. The reason, because like I mentioned in the disclaimer, so on our point of view, this cloud architect is a person to handle our cloud solution, right? So the cloud architect should have a leadership, at least to convince the developer, and also to convince the higher up on the blueprint of the design. Okay, so for example, like maybe your CTO is an old school guy who do everything on the servers, right? And because the business cannot cope with this technology, so you need to convince him at least that to move to the cloud solution. And also if the developer are reluctant to understand the new technology that you're going to provide, and it's going to be a problem. So you need to be a person to lead them, at least. For example, okay, if you don't understand this, I will have some session with you guys 5 days to understand all of this thing, right? At least so to have good leadership is a good thing to have as a cloud architect. And then also to have the business sense. Alright, so because you are solving your company issue, alright, so you need to know the impact on the business. For example, again, the same situation, e-commerce that you have two WordPress developer, right? And suddenly you want to move, and then the business is booming. You have a lot of customers suddenly. So you need to have a quick decision. Okay, now is the right time to move to cloud. Now, because if we hold this new customer somehow, I don't know where they're coming, but it will make it will have an issue with our companies later, because we don't take this advantage currently, right? So there's a lot of other technology advantage. For example, you can see that okay, Kubernetes is very complex. Then somehow you say to make a growth, and you have asked few people, and few people suggesting you to have this new technology, which is for example Google Appengine, right? Google Appengine have like lot of features that suit with the current issue. So as a person who designed the cloud solution, you should say that this is actually good for your company, so you take it. And of course you need to know, for example, Google mentioned this is a beta, then you need to rethink it again lah, because somehow Google, if it's in beta, if they remove it, and you will fuck up. So make sure that you have this business sense for your company growth, right? And then of course the most important part is the planning. So you have this leadership going on, you have this business sense, you have this communication. You already tell your boss, your developers, that we are going to have this. But then to transition between old technology to new technology, or old architecture to new architecture, you should have a business plan. You should have a action plan. So actually, for all of this key skill, I will show you how Runcloud do on our architecture that we have on all of this. Alright. So now we move to the journey of Runcloud architecture. Okay. So this is where the things that interesting for sharing part. Alright. So okay. On Runcloud start around 2016. So it's like almost 5 years, more than 5 years. Back then it's in university lah, UTM. Alright. So it's developed by our CTO, Jebat, alone. So Jebat create this using Laravel, and he hosts the Runcloud on Linode server. Linode is a PaaS, platform as a service provider, and at that time we are using Node.js as our agent, communicator agent. And then around that time, Node.js have not have an issue, but its code is very not suitable for small agent, small communication stuff, and we move it to Golang. And Golang actually just started back there, not just started lah, just get famous. Okay. So we are using Golang, and until now we are using Golang, and it's actually awesome language, very easy to learn. And then we stored our data on S3, and we are using CDN lah, CloudFront, so to manage our, because our user even at this time we are targeting internationally, so most of our users are from US and UK. So basically we are using CDN to fasten the web application. And then we move to the second era, which is a microservice era. Alright, so problem with this monolith era, when the users when there's new user keep coming register to Runcloud, right? So then we upgrade the server. Then new user coming, and then we upgrade the server again. Then and suddenly, boom! At one night, so many user register at the same time. So this architecture, cloud architecture, actually cannot cope with the current business. So we move to the microservice era, which is we separate the services to 7 different services. Alright. So at that time, even actually we move from Linode to DigitalOcean. Actually, Linode and DigitalOcean is a similar platform. Not similar platform, similar business. It's a platform as a service. But DigitalOcean have more, I can say, Linode at that time when they want to close your server or they want to maintain your server, they will turn it off. So we are really like, hey, suddenly turn it off. Then all our users are complaining, why suddenly we cannot do some update, right? As they're like, oh no, this is Linux stuff. And then we move to DigitalOcean lah. And actually at this time, our CEO have like engagement with DigitalOcean. They go to the office and everything, and we got like very special price to hosted our solution on DigitalOcean, right? And then at this time using Golang entirely, and also we have atomic deployment, our own CD continuous deployment, our own CD deploying our own code base, right? And then we have a load balancer by DigitalOcean because Linux doesn't have the load balancing. I think even now they don't have it. I'm not sure if they have it or not. But in DigitalOcean, you actually have the balancer server to maintain the server lah. This time, because we are using Microservice, right? So we have around, I think, two gateway server and two service server. So service server actually the server that connecting to all our customer servers, right? But still, this era, we still have the issue. Last time DigitalOcean, Linux, they turn off our server because to maintain it, right? In DigitalOcean, still they have similar issue, which is they turn off your. I think in this DigitalOcean we have this vulnerability, Spectra and Meltdown, something like that. It's more on the CPU level, is it? So DigitalOcean close few of our server, and I think we also have issue lah. Then our CTO are thinking, and also at this part, the problem is with the database. So we are hosting the database on DigitalOcean database server, but it's still spiking, and we cannot actually determine lah which is actually the issue. So at this time, the engineering team, we decide to move to AWS. Alright, so this is a platform service. AWS is infrastructure service. So we move to AWS. So currently we still in AWS era. So nowadays, Runcloud hosted our solution in AWS. So with AWS, basically we become more secure because we are using VPC. So few of the service, because last time in DigitalOcean, we are using data table. Is it table for firewall? I'm sure I forgot the name. So it's very hard for us to configure lah. But then in the AWS, we are using VPC. So we actually we can choose which server can have connecting to outside. Alright, so it's very very good to have for this AWS. And then we move our database. Previously in DigitalOcean, we move to database RDS, and we're using Aurora. So actually this when we move to RDS, actually it's we're solving a lot of issue. And previously our database is scattered among the servers, so every service have its own database server, a small one lah. But then in RDS, we move all of the server in actually one big server with a replication. So later I will show you guys the more in depth on this RDS. Alright, so and then we have AWS load balancer, similar to DigitalOcean load balancer, is the same thing. And even few of our services, we are using serverless. So actually this night I want to talk about serverless more, but I cannot do it the tools or the materials on time. So I show you guys the big picture of the serverless today lah. Right, and then we move to few of our services, we move to serverless. Alright, so on AWS era, the most complex part is actually on database, or for cloud architecture lah, database migration. Alright, so imagine before this we have all our the database scattered among database server, right? So how we migrate basically we are using AWS database migration service. AWS have this solution. So this migration support homogeneous and heterogeneous migration. So homogeneous is same database to the for example MySQL to MySQL, and heterogeneous is more like from MySQL to NoSQL. For example MariaDB. For example MongoDB. Right. So this one is heterogeneous. So AWS database service support many DBMS. Support Postgres, MySQL, MariaDB and everything, and also support data transformation for heterogeneous. For example, if you want to store, previously we store our log in one MySQL, right? Then we move it, we transform it using NoSQL because log is better on NoSQL instead of MySQL. So we doing that, and then on the migration we also have the ongoing replication. So because of we have this ongoing replication, the transition between our Microservice Era to AWS Era, so for database actually we don't have much downtime. The only downtime that we have at that time is actually because on deployment we wrongly backup our web application. So that is actually the downtime. But on the database part, it's actually there's no downtime, because previously when we move from Monolith Era to Microservice Era, we take around 48. I think around more than 48 hours just to migrate the database. So imagine that, right? So we don't have that issue anymore on this AWS Era. So the reason why we use AWS Era, okay, so actually the person who instruct us about this cloud architecture is actually a consultant from AWS himself. So he designed this. He helped us developer because Runcloud doesn't have cloud architect. So he basically the cloud architect, the consultant came to us and say better move everything to Aurora, better to move everything using VPC and everything. So we take his advice and we move to Aurora, and basically up till now we don't have any database issue. If we have issue, we have actually web application issue or CPU spike, something like that. So for this Aurora, so basically Aurora have effective replication. So I think as of now we have read and write. We have 3 read endpoint and 1 write. I think write is only on master, and we have like slave database for read 3, something like that. So and then we have better monitoring metrics, so we can actually monitor the performance. We can see few of our query is very slow query, and when we check, actually we can make it faster by indexing. So that's the best part on the Aurora. And then we have failover. For example, if okay, this failover is quite funny because for Aurora they support multi available zone. So for example, you can put your database in US West, then you need to have like replication in maybe Europe. Okay, so if the US data center turn off, then actually you have a Europe as a backup, right? So it's very good to have failover. But because we wrongly put the replication in the same region, so somehow last time AWS have some issue on US West, then and then the database is not working. So it's like, we have the replication, then why is the failover is not working? So basically because we wrongly put the location. But now I think that one is already solved, and then it's very easy to scale because it's AWS. So for you to scale is similar to like in DigitalOcean. You just need to scaling your database. I think even for replication we have the AWS database migration, right? So it's very easy, and we have the auto snapshot. So previously backup we are using manually MySQL dump, but after we have Aurora, so they have like auto snapshot. So for example, on the new release, if for example on the release new release, there's something issue with the database. So basically we can like revert back to the previous one. So it's very easy, right? So actually it's very helpful lah. And also like I mentioned, we have support. They have support multi-exec. Alright. So then I will talk about the serverless. I think there's few slide left. Okay. So what is the best thing about serverless? So actually I wanted to show this, but we don't have time. I don't have time for that. But basically one of our issue or one of our solution, this one is internally lah, because we using serverless actually just for experimenting. So our finance, we have so many clients, and because our subscription is monthly, and we have up till now we have around 70 users, 70,000 users. So very quite a lot, right? So the number of receipt is actually a lot, even for 1 month. So our finance want to have this receipt to be downloaded for their auditing. So our developer actually previously we are using Laravel. Alright, so this is the graph that I show you. If we are using Laravel, it will take around 500 seconds to process 5,000 receipt. So basically the process is actually quite simple. List all the receipt in Excel file and generate the receipt PDF. So that's actually quite not a very complex code, but the process is complex on the Laravel. So actually for the Laravel we are using queue and everything. So at this time when we do this, so you can see here PHP, Laravel is PHP PHP is very so PHP is very slow. So we in the graph you can see in Node.js we use the same code, not same code lah, same logic, and it actually can process 15,000 receipt in 400 seconds. So then we realize, okay, Node.js is PHP actually quite slow. So then we are using Node.js. But then our developers says local is okay, but to have once because we are using i7 CPU, 60 GB RAM for this one is local lah. So very expensive to have this spec as a server. To only to have this issue, and this receipt actually using by the finance once a month. So very pointless, right, to have this big spec. So then what the developer say, he want to try serverless. Then we move everything to Lambda, to serverless. So basically the Lambda option we use very small. Actually even till now is still free. They have free tier, right? So and then memory we only set 1.5 GB, and you can see here it take less than 100 seconds to finish all of the receipt. So that's the reason why we are moving to serverless for few process. Alright. So basically the concept or the code is totally different from what we have in Laravel, and also in the not local, because you need to code the logic on the serverless framework. So we are using Lambda. So basically this is how it works lah, right? So I give you the quick explanation on this. So basically what the developer trying to do, we are using MapReduce. So MapReduce, I think it's a common, is it common? I think it's a common tool for data analytic, not data analytic, data processing. Okay, so maybe a few of you guys out there is AI developer or maybe data scientist, right? So you are quite familiar with this MapReduce stuff lah. Right. Okay. So what we do actually, for example, if the finance wanted to have 15,000 receipt in monthly, they will so our system actually will send this 50,000 record to API gateway. Okay. So actually 50,000 record to API gateway is not that big deal. It's very small because it's a text, so it's very small. But to process that 50,000 data, that is the main challenge. So what we do here, actually we have this HTTP handler. So basically HTTP handler, I think it's a common Lambda setup that you have a HTTP handler. So HTTP handler basically it will receive the data from outside lah. For example, this one is we send it from our panel. Then from that 50,000 received, basically we chunk it into 100 record. Alright, so we don't actually send everything in one go. We still send it 100 record. So that 100 receipt will be added into a map queue. So map queue basically we put it one by one, 100 cells in every queue. So in Lambda, because the map queue, you can spin multiple queue without any issue. So you cannot do this in without in container. In container can, but it will be tricky, and also you cannot do this on server stuff. Server spec is very hard. So with Lambda, actually you can have like, imagine we have around 150 queue, and we do, and this 150 queue we map it using the map function, and then that map function basically process it will generate and PDF and report lah for the data that we send. Alright, so limit of the Lambda process at most 1k cells only. So basically on the map function we process 1000 cells only at one time, but because Lambda can scale automatically, so at this part actually we the map queue trigger 15 of the map function, and that 15 map function, it will create buffer, for example like PDF and CSV number 2, number 3 up to number 15, and then after all the map function already written on the database, it will trigger the reduced queue. The reduced queue basically obtain the record of which map have done this, which map have done this, and it will trigger the reduce function to merge everything into one. So this is the not complexity, the way that we do it. And at the last, we will remove all the stage. For example, like if there's a missing data or everything, and using the cleaner function. Alright, so that's how we handle. That's how we can get this 15,000 receipt 1 month into like less than 100 seconds. So because we are using this serverless, so actually quite awesome to have this solution. And when we stumble upon on this solution, we kind of like few of our service should move to this serverless lah. Alright. So, and basically the new era for Runcloud, actually we are moving to a container era. So we already started few last year lah, but up still now we still in AWS era. But our CTO basically already started to move everything to container, and we will move to container era, because till now we still have this CPU spike issue in AWS, and even we have been stopped to monitor and at the new server, still it's not enough. Probably we will move to container era to reduce our cost and optimize the performance. So, but this is a different story lah. Later, when we have it, I will share again to Krenovator. Alright. So now on the last topic, I will show you the cloud solution that we have currently. So we have platform as service, like I mentioned. We have Appengine, we have Heroku. I think you guys already have the session, right, with Heroku. So basically they give you the platform and you code on it, right? So they have a Netlify, DO app platform, and then for example, my experience, I'm using Appengine before. So for Appengine, it's very less server configuration. You just need to code it and deploy, and scalability is handled automatically lah. So similar to like we have in serverless, so it auto scale. So for example, if you have some sales suddenly, for example like 4 sales, and then end user sale. So then all users go to your e-commerce site. Your web app or your e-commerce won't be an issue because it automatically scale. And then the cons is most of the server are config, can tune according to your need. Okay, for example, like if you want to have fast response, you cannot do it because Appengine have like very specific response time. So you can even the small things have similar response time because it have like scheduling lah. So that's the reason lah. Or can you see like CPU still something like that. And then cost can be expensive if we starting out. So for example like Appengine it's not cheap lah. It's very quite expensive. And because it use its own code base, or not code base code configuration. So you need to have like learn how Appengine works. And then but now Appengine have the container base, but still you need to learn on how the container base works. And not all solution or all codes that you want to do is actually supported by the Appengine. And then also Kubernetes. Okay, so Kubernetes, hopefully this will be on the next session. I think I will give another session. I already promised to Krenovator to have another session, but it will be on the Kubernetes lah. But this one later I will confirm back to you guys if this topic will be on or not. Right. So I think that's all for the sharing session. 1 hour. So we started at 8:35 and then we end at 9:35. I think it's a good timing for us. So I think that's all from me. I can stop sharing